Hi everyone, so we're going to go over the second practice quiz for quiz 20. Remember, all of these formulas will be given to you on the SOL, which means you don't need to worry about memorizing it, but you do have to recognize which formula to use and when. Number 1 says find the sixth term in the sequence 2, 8, 32, and so on. So our first step is to see, is it arithmetic or is it geometric? Okay, are we basically adding to get the next term every time, or are we multiplying? Okay, so it looks to me like we might be multiplying, because there's no way we're going to get straight from 2 to 8 and then jump from 8 to 32. 2 to 8, let's see, if I multiply 4, that could work. And 8 times 4 is actually 32, which means this is a geometric sequence. Okay, and we multiply by 4 every time, which means if you look at your formulas under geometric and we want A, the formula we're going to need is AN equals A sub 1 times R to the N minus 1. Okay. N is which spot, which place we're looking for, and it's telling us we're looking for the 6th place. So right now we have the 1st place, the 2nd place, the 3rd place, and if we kept going, we would need to go to the 4th place, 5th place, and then 6th place. What would that answer, what that number would be? So I want A sub 6. A1, that means what's the first term? So A1 is the first place or first term, and it looks like it's 2. So A1 is going to be 2, so that's what I'm going to plug in. 2 times R is what we multiply by every time, the ratio, and we multiply by 4 every time. So 4 is going to be our R, and we said N was 6, so 6 minus 1, which is technically 5. Now this is where PEMDAS comes in. You first have to do 4 to the 5th power. So I turn on my calculator, I'm going to do 4 to the 5th power, whatever I get, multiply it by 2, and we get 2048. And that is going to be our answer. Okay. Next up, we have another problem that says, now we're finding the 10th term, so automatically N is going to be 10, in a geometric sequence. Lucky us, they told us geometric, so we don't need to actually think about it. The first term is 5. That translates to A1 being 5. And a common ratio, so R is for ratio, of 2 divided by 5. Which means we're going to use the same formula as before. AN equals A1, R to the N minus 1. And they told us everything we need. Next up is just plugging it in. A1 is the first term, which is 5. R they said was 2 over 5. N minus 1 is 10 minus 1. So that gives us 9. Now it's very important, depending on what calculator you have, but just to be safe, make sure your 2/5 is in parentheses when you plug it in your calculator. Okay? So it's 2/5, close your parentheses, raised to the 9th power. And it's okay to get e to the -4th. Those of you who took chemistry, you know, you just move the decimal 4 places to the left. But I don't need to do that just yet. I'm going to times it by 5, and we actually end up A10 to be 0.0013. And that's going to be our answer. 0.003, 0.0013, my bad. Alright, not too bad. It's just making sure what formula you know. This third problem I think is the most challenging for you guys, but it's just basically repeated process over and over again. Okay, so the following sequence is given in recursive form. Okay, what is the value for the third term? That means we are looking for A3, because N is 3. They give us the formula and they gave us the first term. If I tried to just go ahead and look for 3, so A3 equals 3A, 3 minus 1 plus 1, A to the 3 is 3A to the 2 plus 1, but I don't have A2, right? I only have A1, so I can't do this just yet. So my first step is going to be find A2. Recursive means you have to find everything in order to the number we want. So we want A3. That means we have to go from A1 to A2 and then A2 to A3 to get our answer. There's no just plugging it in one time and getting an answer. So to find A2, I'm going to use the formula. So it becomes 3A to the 2 minus 1 plus 1. 2 minus 1 is 1. And it turns out A1 is something we have. That's 11. So I'm going to go ahead and plug it in. So it becomes 3 times 11 plus 1, right, which becomes 34. That's A2. We want A3. Well, after 2 comes 3, so we're going to try and do that now. 3 times A minus 3 plus 1 plus 1. 3A2 plus 1. Now I have A2. Okay, it didn't work before, but now I have it. So I'm going to plug the answer I got before into this problem now. So it becomes 3 times 34 plus 1, which is 103. So A3 becomes 103. So it just becomes being familiar with finding A2 and then using that answer to find A3, and if you needed to, you would keep going. Luckily, we only had to go up to A3, so not too much time was wasted. Right? All of these were sequences. Sequences are just lists, right? We want to find the X place in the list. Here, our next problem, right, the sigma means we have a summation or a series. That means everything in our list we are adding. So the bottom says what to start with, so we're starting with 1, and the top tells us add 1 all the way to what? So we have a list of 10, and we're adding every single term. Now that would be a lot if we tried to go ahead and find every single term. Thankfully we have a formula, but just like before, we need to figure out, is it arithmetic or geometric? Okay. This has an exponent. Right? It's 1/5 to the x power. So whenever you have an exponent, that's going to be geometric. Right? If you just had plain multiplication, that's arithmetic. So since it's geometric and it's a series, right? S for series, S for sum, we're going to use the formula Sn equals A sub 1 times 1 minus r to the n all over 1 minus r. Okay? I know it looks pretty scary, but all we have to do is find the A1, the n, and the r, which we can definitely do. So n is always going to be the top number of our sigma. This time it's 10, so n is going to be 10. Okay? A1, remember before, A1 was always the first place in the list. So I'm just going to plug in 1 for x. So it becomes 3 times 1 over 5 to the 1 power, and I have to do PEMDAS. So exponents first. 1/5 to the first power is still 1/5, times 3 is 3 over 5, which means A1 is 3/5. Alright, letting the video catch up. I don't know why it's lagging. Alright, now to find R. R is the ratio, what we're going by every single time, and that's the base of our exponent. So the base is 1/5, that's our ratio, 1/5. Now I have all three things, plug it in. A1 we said was 3/5, 1 minus R was 1/5, and N was 10. Okay. All divided by 1 minus our R, which is 1/5. It looks like a lot, but we're just going to apply PEMDAS. So 3/5, parentheses. Let's go ahead and check that out. Have to do my exponent first. So 1/5 raised to the 10th power. And then I'm going to do 1 minus that answer to get 0.999 blah, 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 blah. And on the bottom, I have to do 1 minus 1/5, which is 0.8. So I'm going to take 0.99999. See, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 8, 9, 7, 6 times 3/5 divided by 0.8, and we get 0.749. And that would be our answer. So s to the 10th power is going to be 0.75 if we wanted to round. There is a way to do it on your calculator as well if you have the newer calculators. I believe if you hit math and you scroll all the way down to summation, you just have to plug in everything. Okay. So it's x equals 1, go up to 10, 3 parentheses 1 divided by 5 raised to the x power. And you notice we get the same exact answer. Okay. And that's the first page. Flip on over to the next one. Okay. It says find the infinite. So infinite sounds like infinity. So that's the formula we're definitely going to use, which is a1 over 1 minus r. So to find a1, that's the first term. So if I look at my list, the first term is 81, super easy. And to find r, it's always the second number divided by the first number. So for second number is 27. I'm going to divide it by 81. 27 divided by 81 is about 0.3 repeating, which simplifies to 1/3. Now all I have to do is plug it into my formula. 81 divided by 1 minus 1/3. So 81 divided by 1 minus 1/3. You end up with 121.5. Right? Not that difficult. Main thing here is, do you know where the formula is and how to find r and a? Okay? Not too difficult. Next up we have the SOL functions. It says the parent function is shown. Which of these graphs belongs to the same family? So if we graph it, which of these has a similar shape or look to our graph? Okay, you guys can easily plug each of these into Desmos. I can tell this is a rational function, which is a fraction. So automatically, you should know it's D. Okay. Next up, which of the following functions does not have a range of only the real numbers greater than or equal to 0? Okay. So basically, graph all these, look which one does not have a range from 0 and up. That one I'll let you guys try out on your own. Right? That wraps up the unit. Again, formulas provided. Just have to know which formula to use when and how to find each piece. Okay? Good luck studying.